Hello everyone. Today I am going to discuss the mass spectroscopy. In this topic, we are going to discuss the principle and instrumentation presented by me. In the first point, we are going to discuss what is mass spectroscopy. The mass spectroscopy (MS) is an analytical chemistry technique that helps to identify the amount and type of chemicals present in the sample by measuring the mass to charge ratio and relative abundance of gas phase ions. That is, in this instrumental technique, the sample is first converted to rapidly moving positive ions by electron bombardment of 70 electron volt voltage, and charged particles are separated according to their masses. Now, the mass spectrum is a plot of relative abundance versus the ratio of mass to charge. Next, these spectra, which are observed from the mass spectrum, which is a plot of relative abundance versus mass to charge ratio, are used to determine the elemental or isotopic signature of a sample, the masses of particles and of molecules, and to elucidate the chemical structures of molecules and other chemical compounds. Now we are going to discuss the introduction of mass spectrometer. Actually, in this mass spectroscopy, the compound under investigation is bombarded with a beam of electrons with a 70 electron volt, which produces an ionic molecule or ionic fragments of the original species. Then next step is that the separation of resulting assortment of charged particle is done according to their masses. When charged particles are converted according to their masses from the spectrum produced known as mass spectrum, which is a record of information regarding various mass produces and their relative abundance. Thus, the mass spectrum is an analytical technique which can provide the information concerning with the molecular structure of organic and inorganic compounds. This is the one of the application of mass spectroscopy. Also, it can be used to determine directly molecular weight as high as 4000. Mass spectroscopy is one of the few methods that can be used as a qualitative analytical tool to characterize different organic substances. With this, one can do the analysis of mixtures such as gases or liquids, or in cases solids also in quantitatively. Here, the mass spectrometer is also useful to investigate the reaction mixtures and in tracer work. Also, it is used to understanding the kinetics mechanisms of molecular decomposition reactions. Although the mass spectroscopy is based on the simple principle, yet it is a very complex and very expensive instrument. Also, now it is becoming a common tool because it gives the large amount of specific information about the substance to be analyzed. Now here I am showing to you the schematic representation of this mass spectrometer. It consists of four different stages. First stage is ionization 1. Here the molecule is ionized with bombardment of high-speed electrons with 70 electron volt. Thereby the molecule is converted into a ionic stage by getting a mixture of complex fragments. In accelerator, the second part is about accelerator. Third part is about deflection and fourth part is about detection. All the information I am giving to you one by one. See, let us see here. This is a three-dimensional schematic representation of mass spectrometer. Already I have shown you the simple diagrammatic representation. In 3D, there is a schematic representation of a mass spectrometer. Here, from the right side, the sample is injected with a source of high beam of electrons. Here, the particles are accelerated into the magnetic field. Then, the mass to charge ratio, that is of a cations which are separated with the help of magnetic field separators, which is based on the mass to charge ratio, and then the intensity of the only cations in terms of ionic current can be detected by means of a detector also. Now we are going to discuss the basic theory for mass spectroscopy. As mass spectroscopy is deals with the examination of the characteristics fragments arising from the background of organic molecules. Also, it is a plot of relative abundance or relative intensity versus the mass to charge ratio. The basic as aspect of organic spectroscopy consists of bombarding the vapor of an organic compound with a beam of energetic electrons accelerated from a filament to an energy of 70 electron volt to form the positively charged ions, and it is called as molecular ion or parent base peak ion. Now, in additional basic theory, the additional energy of the electrons is dissipated in breakdown the bonds in molecular ions, which undergoes fragmentation to yield several neutral or positively charged species. Here, the fragmentation may be yields in the formation of even electron ion and radicals. Thus, various positive ions which are formed that can be accelerated and deflected by magnetic or electric fields. The deflection of ions, however, depends upon its mass to charge ratio along with the velocity. Now, we are going to discuss the principle behind the mass spectroscopy. Here, already I am showing to you the 3D dimensional diagram of a mass spectroscopy. Now, what is the principle? In this technique, the molecules are bombarded with a beam of energetic electrons with energy of 70 electron volts. As the molecules are ionized and broken up into many fragments by bombardment of high energy electrons, some of which are positive ions. Now, each kind of ion has a particular ratio of mass to charge, that is m by e ratio value. For most of the ions, charge is 1 and thus m by e ratio is simply the molecular mass of the ion. Now the ions are passed through electric and magnetic field like this here to reach detector where they are detected and signals are recorded to give the mass spectra. Here I am going to see the instrumentation part for this mass spectroscopy. Here this diagram shows the instrumental path for this mass spectroscopy. First, how the sample is introduced from inlet, then source, analyzer, ion detector, and then through ion detector we get the peak in the form of mass spectrum. Now, we are going to see the steps of mass spectroscopy. First step, that is the sample inlet. Step number 1. Samples are stored in large reservoir from which molecules reaches ionization chamber at low pressure in steady stream by a pinhole called as molecular leak. In the second step, ionization, the atoms are ionized by knocking one or more electrons off to give positive ions by bombardment with a high speed stream of electrons. At that time, what happens? Most of the positive ions are formed which carry the charge is equal to +1. Now the ionization can be achieved by, that is in step number 2, this ionization is achieved by following any of the methods. First is electron ionization, second is chemical ionization, and third is desorption technique. Now what is happens in electro ionization, that is in step 2. Here I am showing to you that is the diagrammatic representation of electroionization. This method is most common method of a ionization. Here sample is bombarded by electrons which come from a heated filament, that is from here. His vaporized sample is inletted from this inlet. The electrons run in a stream between cathode and anode. When the sample passes through the electron stream, the high energy electrons, here this type of electrons in the stream, knock the electrons out of the sample to form ions. Now, second method of ionization, that is electrospray mass spectrometry. Here liquid containing analyte is forced through the steel capillary high voltage to electrostatically disperse analyte. Here the charged particles imparted from rapidly evaporating the liquid. This is the diagrammatic representation of a electrospray mass spectroscopy. Third is about, that is matrix assisted laser desorption ionization, which is called as a, in short, MALDI. Here the analyte, that is protein, is mixed with large excess of matrix, that is of small organic molecule, which is irradiated with short pulse of laser light. Wavelength of laser is same as the absorbance max of the matrix. Now, in the step 3, whatever may be the ions are ionized. What is the next step? The acceleration is a simple step where the ions are placed between the set of charges parallel plates. Here these are parallel plates, these are the ions which then repelled by one plate and attracted to the other plate. There is a slit cut, that is this, in the plate in which ions are attracted to the force of attraction and repulsion forces the ions through the slit at an accelerated rate. The speed of acceleration can be adjusted by changing the charge on the plates. Here what happens? Ions are accelerated so that they all have same kinetic energy. Okay. Now positive ions pass through three slits with voltage in decreasing order. However, in middle still slit carries intermediate and finally at 0 volt. In the next step called as a deflection step. In this deflection, ions are deflected by the magnetic field surrounding the instrument. The amount of deflection depends on the mass to charge ratio of the ions. The heavier ions and ions with a positive charge of 2 or more are deflected the least, that is the ion stream C. The lighter ions and ions with one positive charge are deflected on the most, that is on ion stream A. The ions at the correct mass to charge ratio traversed through this detector, that is through ion stream B, that is at point here. Okay, now the mass to charge ratio is determined from the ions that hits the detector. Ions are deflected by means of magnetic field due to difference in their masses. The lighter the mass, more they are deflected. It is also depends upon the number of positive charge and carrying more the positive charge, more is the deflect ions are the deflected. Then the last step, that is the detection. In detection, when the ion stream reached the detector, they hit a wire. On hitting the wire, they become neutralized by electron jumping from metal wire to the ion. The diagrammatic representation is shown into here. The amplifier picks up on this current being created between the wire and the ion and amplifies the signal being detected. The computer picks up this and converts it into mass to charge ratio, and thus spectrum is produced. I have shown you here the detection, how detection is here takes place. Last step is about, that is the analyzer. The beam of ions passing through the mass analyzer is detected by detector on the basis of which, that is the mass to charge ratio. When an ion hit the metal box, charge is neutralized by electron jumping from the metal to the ion. There are few types of analyzer. First is magnetic sector mass analyzer. Second is double focusing mass analyzer. Third is quadruple mass analyzer. Fourth is TOF time of flight analyzer. Okay. Fifth is ion trap analyzer, and sixth is about ion cyclotron analyzer. Any of the analyzer you can use and analyze the intensity of the only cations. Okay. Thus, the mass spectrum is observed is shown to here you. Okay. Thank you.